हेलो एवरीवन और फुल काइनेमैटिक्स 1D लेक्चर सीरीज में आपका स्वागत है। ये पहला लेक्चर है और इस सीरीज में हम पूरे 1D काइनेमैटिक्स को डिटेल में डिस्कस करेंगे और छोटे छोटे लेक्चर्स में इसको डिस्ट्रीब्यूट करेंगे। तो इस पहले लेक्चर में मैं सिर्फ डिस्कस करूंगा व्हाट इज पोजीशन, डिस्टेंस एंड डिस्प्लेसमेंट। बस ये तीन चीजें मैं डिस्कस करूंगा, पोजीशन, डिस्टेंस एंड डिस्प्लेसमेंट। नाउ व्हाट इज पोजीशन? Position is something. Position is a vector that defines the current location of the particle. पार्टिकल अभी कहां पर है, किस जगह पर है पार्टिकल। अब कैसे डिफाइन करते हैं? मान लीजिए हम बात करते हैं 1D में। लेट्स टॉक अबाउट वन डायमेंशन। दिस इज अ स्ट्रेट लाइन। लेट्स से दिस इज योर ओरिजिन। दिस इज 1 2 3 -1 -2 एंड लेट से आवर पार्टिकल, हमारा जो पार्टिकल है वो यहाँ कहीं एग्जैक्टली बीचों बीच है, एग्जैक्टली इन द मिडल। सो द पोजीशन ऑफ द पार्टिकल विल बी इक्वल्स टू 2.5। अगर एक दूसरा पार्टिकल ले लें, मान लेते हैं इसके बीचों बीच में यहाँ पर, तो द पोजीशन ऑफ द सेकेंड पार्टिकल xp dash will be equals to -1.5. So in one dimension the direction is represented by positive and negative signs. So this is something about position in one dimension. ठीक, अगर आपकी पोजीशन ओरिजिन से राइट साइड है तो यू टेक योर पोजीशन एज पॉजिटिव, अगर आपकी पोजीशन ओरिजिन से लेफ्ट साइड है तो यू टेक योर पोजीशन एज नेगेटिव। चलिए अब हम इस बात को डिस्कस करते हैं, पोजीशन इन 2D। पोजीशन इन 2 dimensions. What is the position in, or what will be the position in 2D? तो वी नो दैट इन 2D एक x एक्सिस होगी और एक y एक्सिस होगी, और इनमें भी एक कोऑर्डिनेट सिस्टम होगा। ये पॉइंट 0,0 होगा, x में ये 1 ले लेते हैं, ये 2 ले लेते हैं, और यहाँ पे ये 1 ले लेते हैं y में, ये 2 ले लेते हैं y में, फिर x में इसे -1 -2 और y में यहाँ पे -1 एंड -2। ओके, नाउ इस बात को समझने की कोशिश करते हैं कि अगर हमारा पार्टिकल कहीं यहाँ पर है, यहाँ पर मतलब कहाँ पर, ये बीचों बीच x में 1 और 2 के बीचों बीच और y के 1 और 2 में बीचों बीच, तो पार्टिकल की पोजीशन क्या लिखी जाएगी? पार्टिकल की पोजीशन लिखी जाएगी 1.5, 2.5. The other way of writing the position, the vector form of the position will be given as 1.5 I cap plus 2.5 J cap. Let's take another example. एक मान लेते हैं कि हमारा पार्टिकल यहाँ पर है, इसके उस पे और इसके इंटरसेक्शन पर, -1 और 2 के इंटरसेक्शन पर है, तो इस पार्टिकल की पोजीशन होगी 2, -1, और इसका जो वेक्टर फॉर्म लिखा जाएगा, पोजीशन ऑफ rp डैश विल बी इक्वल्स टू 2 I cap minus j cap. So whenever you are representing 2D position, a two-dimensional position is represented using यूनिट वेक्टर्स। ये ध्यान रखना कि यूनिट वेक्टर्स की हमेशा जरूरत होती है टू डायमेंशनल पोजीशंस को रिप्रेजेंट करने के लिए। विद यू कैन नॉट रिप्रेजेंट टू डायमेंशनल पोजीशंस जस्ट बाय साइंस, you have to use the concept of I cap and J cap. Now let's talk about position in 3D. What would be a position in 3D? How are we going to define a position in 3D? So in 3D there will be three axes, x axis, y axis, and there will be a z axis. This z axis is drawn on the screen but it is actually coming out of the screen. ये स्क्रीन के अंदर बनाई गई है, बट अगर आप सही मायने में सोचो तो ये z एक्सिस को स्क्रीन से बाहर की तरफ निकलना चाहिए, क्योंकि हम 3 डायमेंशन की बात कर रहे हैं। नाउ एक पार्टिकल की पोजीशन हम कैसे डिफाइन करते हैं? लेट्स से x एक्सिस में मूव करते हैं सम डिस्टेंस 2, y एक्सिस में मूव करते हैं सम डिस्टेंस 1, और z एक्सिस में मूव करते हैं सम डिस्टेंस, let me explain this to you. We are moving along negative z axis. z axis में मूव करते हैं सम डिस्टेंस -3 और हम पहुंचते हैं एक पॉइंट P पर। तो what would be the position of point P? The position of point P drawn directly from the origin to point P, ये वेक्टर्स को रिप्रेजेंट, ये जो ब्लू वेक्टर है इसको रिप्रेजेंट करने के लिए this vector would be the position of point P. So the position of point P would be given as 2 I cap, I for x axis, plus j cap for y axis, and minus 3 k cap for negative z axis, minus for negative z axis. And that is how you are going to define your position. We can take another example here. एक और example लेके समझते हैं. Let's say this is x axis, this is y axis, and this is z axis. And x axis में we moved negative -2. Then along z axis we move positive +2. And then along y axis we moved +1 or maybe +2. Why do we care so much? Let me remove this +2 from here and write it here because there would be less confusion. And this is your +2 again. And you have reached your point P dash. So what would be the position of P dash? The position of P dash, or this blue vector starting from the origin, position of P dash would be given as -2 I cap, and this is not -2, this is +2, my mistake, -2 I cap, +2 k cap, and +2 j cap. So +2 j cap, +2 k cap. और आप देख सकते हैं we are reaching at two different points. Here we are reaching somewhere, you know, behind x axis. Here we are somewhere ahead of x axis, and this way we can define positions along 3 dimensions. So this is for position in 3 dimensions. Position in 3 dimensions. And for x axis we represent x axis with I cap, y axis with j cap, and z axis or z axis with k cap. Now let's move on to the next important thing, and that is displacement. अब डिस्प्लेसमेंट को डिफाइन करने का सबसे सिंपल तरीका क्या हो सकता है? What could be the most efficient way to define displacement? जनरली आपने क्लास 9-10th की जो डेफिनेशन पढ़ी है, क्लास 9-10th की जो डेफिनेशन पढ़ी है, दैट सेज शॉर्टेस्ट डिस्टेंस बिटवीन 2 पॉइंट्स. Now this definition is partly correct, but it is incomplete. Incomplete definition. और ये incomplete definition क्यों है, उसका रीजन अभी आपको जस्ट थोड़ी देर में समझ में आएगा. I'll explain that to you in a moment. The complete definition of displacement is displacement S is equals to change in position or simply final position minus initial position. Final position minus initial position. So this is your displacement. That is change in position, final position minus initial position. The SI unit of displacement will be meters. The SI unit will be meters and it is a vector quantity. That means it has direction. Displacement has a certain direction. अब इस बात को समझने की कोशिश करते हैं कि why is this definition incomplete, and from there we will take an example from that definition, and the new definition we will try to understand it with an example. So let's discuss something in 1D example. This is a 1D example. This is a 1D example. Now what's a 1D example? So this is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Now it is said that a particle starts from 1, goes up to 4, and then returns back and stops at minus 2. A particle starts from x equals to 1, a particle starts from plus 1, goes up to 4, returns back and stops at minus 2. और आपसे लोगों ने पूछा कि what is the displacement? So the displacement is simply going to be final position minus initial position, and that is going to be equals to final position is minus 2 and initial position was 1. ध्यान देना, this minus comes from the formula, this formula. So don't say कि 1 पे नेगेटिव साइन लगाया, नहीं, 1 पे नेगेटिव साइन नहीं लगाया. This minus comes from the formula. So please try to remember that. And that is equals to minus 3. So the displacement is minus 3. Let's have a look at another example. So 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. The particle now starts from minus 1, goes up to minus 2, and then returns back and stops at 4. Now somebody asks you what is displacement. You will say that 4 is the final position and minus 1 was the initial position. So we will have displacement equals to 4 minus 1, final position minus initial position, and that will be equals to 5. अब इन दोनों में फर्क क्या है? I want you to understand here. I'll bring that diagram a bit down so that we can have it in a single frame. इन दोनों में फर्क क्या है? Let's see. What is the difference between these two? यहाँ पे आप अगर पहले वाले डायग्राम में देखोगे तो the net motion of the particle is backwards. Motion of particle is backwards or towards left. So I'll just say backwards. And that is why you are getting a negative answer. That is what a negative answer means. Negative answer का मतलब ये होता है कि net motion of the particle जो है वो पीछे की तरफ. और यहाँ पे आप देखोगे तो the net motion of the particle is forwards. ठीक है, और इस वजह से इसका आंसर पॉजिटिव है, इस वजह से इसका आंसर जो है वो क्या है, पॉजिटिव है। ऑलराइट, तो यहाँ पे जो नेगेटिव और पॉजिटिव आंसर्स आ रहे हैं वो इस बात को दिखा रहे हैं कि हमारी डायरेक्शन क्या है। So the negative and the positive answers are actually representing directions, and that is what you have to understand. Now let's consider a two-dimensional displacement. In two dimensions, we will have x-axis, we will have y-axis, and I have a point here, let's say 1 comma, not 1 comma, 1 comma 3, and let's say I'll have a point here that says 6 comma 1. And a particle starts from 1 comma 3, takes some path, moves around, and then reaches to 6 comma 1. Now how do you find out the displacement? तो सबसे पहले ये आपकी इनिशियल पोजीशन देख लो, फिर ये आपकी फाइनल पोजीशन देख लो, और फिर आप फाइनल पोजीशन से इनिशियल पोजीशन को सब्ट्रैक्ट कर दो, and that is how you find your displacement. So the displacement is going to be, the formula does not change, it will be r final minus r initial. Now we all know that in two dimensions final position is given as 6 I cap plus j cap, initial position will be given as I cap plus 3 j cap, and the difference is going to be equals to 5 I cap minus 2 j cap, and that is your displacement. Okay, we can take another example if you want. So this is x axis, this is y axis. Let's say यहाँ पे हमारा एक particle है, this is 4 comma 3, and this here is minus 2 comma 1, right? And this particle इस तरह से ऐसे घूम करके आया, ठीक। Now how do we solve this? So this is your initial position, this is your final position, r final, and we'll always subtract the final position from the initial position, and your displacement is going to be equals to r final minus r initial. This red line here is what represents your displacement, this red line here is representing your displacement, ठीक है। तो फाइनल पोजीशन कितनी हो गई, फाइनल पोजीशन हो गई minus 2 I cap plus j cap, 4 I cap plus 3 j cap, and we are going to have minus 6 I cap minus 2 j cap, and that will be your displacement, right? Now why is the answer, now the question is why is the definition shortest distance between 2 points, shortest distance between 2 points incorrect? ये जो definition है ये गलत क्यों है? ये गलत इसलिए है because when you are actually looking at shortest distance between 2 points, it could be, ये possible है कि 1,3 से 6,1 गया, या फिर ये भी possible है कि 6,1 से 1,3 गया। तो shortest distance वाली जो definition है उसमें direction का पता नहीं चलता है, उसमें डायरेक्शन का पता नहीं चलता है। द रीजन बीइंग दैट इन दिस डेफिनेशन वी विल नेवर गेट टू नो द डायरेक्शन, वी विल नेवर गेट टू नो द डायरेक्शन, and that is why this is incomplete. Now let's finally look at the last thing, and that is distance. What is distance? Distance is the length of the path taken by a particle. इसे वन डायमेंशन से समझने की कोशिश करते हैं. Let's try to understand this using one dimension. Okay, so this is 0, 1, 2, 3 and 4, and this could be -1, -2, -3, and a particle starts from 2, goes to 4, returns back and reaches -3 and stops. So this is what we call as the initial position of the particle, and this is something that we could call as the final position of the particle, and this is the entire path of the particle. Now if somebody asks you what is the distance traveled, and the simple answer is we will find the length of the path. हम देखेंगे कि particle कितना path cover किया. So going from 2 to 4 is a length of 2 units. From 2 to 3 1 unit, 3 to 4 2 units. Now returning back 1 unit, 2 unit, 3 units, 4 units, 5 units, 6 units and 7 units. So forward 2 units, backward 7 units, and total distance is equals to 2 plus 7, and that is equals to 9 units. Now what is the important thing here? The important thing here is that the direction is not important. The direction is not important, right? I mean, going forward and moving backwards does not make any kind of problems. It does not create any kind of problems. All you have to do is आपको directions add करते चले जाना है, एक के बाद एक आप उसे add करते चले जाओ, ठीक है? So the direction is not important. All you have to do is add, and hence distance is a scalar quantity because the direction is not important. Since the direction is not important, distance becomes a scalar quantity. Okay, so this is how your distance works. We can see this in 2 dimensions also. तो चलो एक 2 dimensions का example लेते हैं. So we could have an example like this, the example of a circular motion in which there could be an x-axis and a y-axis. And okay, so I'll draw a y-axis here and let me mark them x and y. Now I'm interested here is in this key. My particle starts from P and moves and moves and moves. Let me draw this with green color, and moves and moves and moves on this circle and comes to Q. Now this is the initial position. P here is the initial position, which I will show by R initial, and this is the final position that I'll show by R final, and this is how the particle has moved. And let me tell you one more thing, that the radius of the circle, let's say, is 2 meters, and the angle is let's say 120 degrees, or this could be 60 degrees as well. Now the question that is being asked is, what is the displacement and what is the distance? तो डिस्प्लेसमेंट इज सिंपली द फाइनल पोजीशन माइनस इनिशियल पोजीशन। अब सवाल ये उठता है कि हाउ आर यू गोइंग टू फाइंड द फाइनल पोजीशन? So the best way to find the vector form of final position is to use vector resolution. Vector resolution. So this angle is 120 degrees, or you can say this is 60 degrees, and this is 2 units. So this will be 2 cos 60 degrees. And this thing here is going to be 2 sin 60 degrees. Now एक और important चीज़ है, 2 cos 60 degrees प्लस नहीं होगा, माइनस होगा, because this is not going along positive x-axis but it is going along negative x-axis. So how do I write the final position? कैसे लिखेंगे? So minus 2 cos 60 degrees for this thing, this part here, I cap plus 2 sin 60 degrees j cap. So this is going to be minus I cap because cos 60 degrees is half, we all know this, and this is going to be root 3 j cap. अच्छा, अगर आपसे कोई पूछे what is your initial position, तो what are you going to say? Initial position is along x axis, so we will simply write it as 2 I cap, and the displacement becomes obvious. What is the displacement? The displacement is obvious. The displacement will be equals to फाइनल पोजीशन माइनस इनिशियल पोजीशन। अब अगर आप डिस्प्लेसमेंट को देखना चाहते हैं डायरेक्टली तो हम ऐसे देख सकते हैं, यू कैन सी इट लाइक दिस, दिस इज योर डिस्प्लेसमेंट and it is final position minus initial position. The final position is given minus I cap plus 3 j cap minus initial position, I'm sorry, root 3 j cap, my mistake, minus 2 I cap. So if we are going to write down the displacement, it is going to be equals to minus 3 I cap plus root 3 j cap, or you can take root 3 as common, minus root 3 I cap plus j cap. Now how do you find out the distance? Finding distance is easy if you know a very important formula. What is the important formula? The important formula is that the length of an arc is radius times the angle. The length of an arc is radius times the angle, provided that the angle is in radians. That is L equals to r theta, and where do I write it? L equals to r theta, where theta is in radians. So I do not want to go into a new page right now. So 120 degrees in radians is going to be 120 degrees in radians is going to be 2 pi by 3, and the radius is 2 meters. So obviously the distance becomes 2 into 2 pi by 3, and that will be equals to 4 pi by 3 meters if it is in meters, or centimeters if it is in centimeters. I mean whatever the unit is, हम वो unit उठा लेंगे और यहाँ पे लिख देंगे. Okay, so we'll use a very simple formula to find out the distance, that arc length is equals to radius times angle, where angle is in radians. So this is your arc length, radius is 2 units, angle is 120 degree, but we need it in radians, so 120 degrees 2 pi by 3. I want you to see and convert it for yourself. अगर आपको नहीं पता है तो we might discuss it in some other section, but right now 120 degrees 2 pi by 3. So 2 pi by 3 times the radius, and that is equals to 4 pi by 3 meters or 4 pi by 3 units, depending upon what unit we are using. So these are your 4 definitions. Okay, so we will meet in the next lecture, right?